Now if I do this, since these are both raised to the n, can't I write that as e over pi to the n? This part? And then I still have a pi down here, don't I? So can't I say times 1 over pi? Pardon me? We just said that if you have something to the n power, it's going to converge or diverge. It just depends on what that is, right? So for us in this problem, we want to recognize that this right here is our r. Now tell me about that r. Is it bigger than 1, less than 1? What's the deal with that? Less than 1. What's e, approximately? E is approximately 2.718, something like that. And what's pi? 3.14. So 2.718 divided by 3.14. That's going to be smaller than 1, isn't it? So this right here is less than 1. And of course, the absolute value of it is less than 1. So it's going to, this right here is going to head out to 0, isn't it? This constant out here, 1 over pi, has no impact on it. It's just some constant. That's never changing, right? 1 over pi is just there the whole time. So this thing will go to 0. So this a sub n goes to 0. Questions? Okay, how about this? This whole section, your homework assignment, is going to be a bunch of sequences that you have to find the limits of. Some of it's going to be converted over, go use L'Hopital's rule. Some of it's going to be just doing some breaking down. I mean, there's a bunch of things on the table here that we can use. Here's another good example. 2n plus 1 factorial over 2n plus 3 factorial. So now I'm starting to bring in the factorials. We talked about those last class, right? So if you think about as n gets bigger, right? As n gets bigger, this thing right here should get huge, shouldn't it? And so should this. So this is almost like an infinity over infinity. But you can't use L'Hopital because you can't turn this into a function of x. Why can't we turn that into a function of x? Because what about factorials? They're what? Yeah, so yeah, but when we defined factorial, like we wrote, like 5 factorial meant 5, right? Times 4 times 3 times 2 times 1, right? But we never said something like, what's 4.1 factorial? Right? Can we do that? Not here, okay? There is actually a definition for this later, but it's not something you see anytime soon. All right, so we in this class are going to say that the factorial is only defined for the natural numbers. And 0. 0 factorial is what? Did I define that for you last class? 1, right? Okay, so here in Cal 2, we will say that the factorial is only defined for the counting numbers plus 0. But to answer the question, yes, you can do it. There is a way. Okay, but we can't do this because converting it to a function of x means we would have to be able to define it at all the numbers in between the integers, and we can't do that here. So this is out. Plus, what's the derivative of a factorial? Right, because that's what you would need for L'Hopital's rule. What's the derivative of factorial? Yeah, we better leave that alone. So I think it's better if we use the properties of factorials, right, to try and figure out what this turns into, right? So let's just use what we did last class. Let's try and break this down. Do you remember which one I said to grab? You look at these two. The larger one. Which one is bigger, the numerator or denominator? Denominator. And what you do is you start doing the factorial on it. So it's 2n plus 3, and then the next one is times 2n plus 2. So it comes down by 1, right? Next one, 2n plus 1, and I stop when I get to the point where I match the top. And so I put the factorial right there. And it's important for you to understand that that factorial symbol is attached to that parenthesis only, right? Okay, so that factorial on this means I would just keep counting down, but I don't need to because that matches up with the numerator exactly. And then these cancel, don't they? And so if I just rewrite this, then I'm going to have no problem taking the limit of that now, right? If I let n go to infinity on that, I'm going to go to 0. So this a sub n will converge to 0. But you got to be able to do that algebra first.
Will that be like that all the time if the denominator is bigger than the numerator? Because you're always going to have a 1 on top.
As long as you're going to be able to cancel it out.
Yeah.
Yes.
But you will when you stop at the part.
Yep.
Purposely cancel.
If I flipped it though, you see it wouldn't, right? If it were flipped over, then this would be flipped and then that would go to infinity. Only if the denominator is bigger and the numerator has something that's going to cancel. See, what I'm trying to answer your question without getting, like, what if you change that to 5? Okay? Now, you can start peeling off, but what's not going to ever happen is you're never going to get anything to go away. You see that?
Yeah.
So we would, I think we would all kind of agree that that's probably going to still go to 0, but it's not going to do this action that we just did. Do you see what I'm saying? Okay. All right, that was all right? Here's a really good one. Really, really, really like this one. Oh, by the way, I wanted to ask you, because I asked my other class, like, what's the difference between 5n factorial versus 5n factorial? Yeah, so what is the difference between these two, is what I'm asking. This factorial is just on the n. This one's on the whole thing. So let's just take an example. If n is 1, okay, I'm going to make like a little table here. If n is 1, what would this be? What's 1 factorial? 1 times 5? 5, right? Here, 5 times 1? 5. 5 factorial? 5 times 4 times 3 times 2 times 1. This number is completely different than this number, right? So that use of parentheses around a factorial is pretty important. See the difference? Yeah. Another thing with factorial that I want you to know is this will definitely, again, play a big part later. What is n plus 1 factorial? We can rewrite that as n plus 1 times n factorial. This is one of the most commonly used properties of the factorial, is that if you ever have n plus 1 factorial, you can rewrite it as n plus 1 times n factorial. Does it make sense to you what I did here? I wrote the first one, n plus 1, then I subtract, and I write n, and then I just put the factorial. So this is, if you want an analogy to this, if I write 5 factorial, isn't that the same as 5 times 4 factorial? Yeah? So 5 times 4 times 3 times 2 times 1 is the same as 5 times 4 times 3 times 2 times 1. I know that looks like ridiculous, but we actually use this quite a bit. This right here. All right, how about this? N factorial over n to the n. That's n raised to the n on the bottom, n factorial on top.
Does that give infinity?
That's like an infinity over infinity. Can't use L'Hopital, though, because you can't take derivative of factorial. Let's start writing them out, okay? Let's just get a feel for what's happening here. Let's use 1. 1 factorial is 1. 1 to the 1 is 1. So I get 1 first, right? Next, 2 goes in. 2 factorial is 2 times 1 over 2 squared, right? Which is 4. I'm going to write it as 2 times 2. Is that all right? I'm going to do that. I'm doing that for a reason. We all understand that's 1/2, but keep going. N is 3. 3 times 2 times 1, right? Over 3 cubed. 3 times 3 times 3. Bottom, you think the bottom's winning here? Let's see, what's 4 factorial? 4 times 3 times 2 times 1 over 4 to the 4th. 4 times 4 times 4 times 4. Right? What do you mean cross out?
Like, what's on top of each other? Or no?
You could cancel out these 2's and make that a 1/2, and then this is all you could cancel here, right? And this, right? And then you still have to figure out what's happening there. Does everyone kind of feel like the bottom's going to win? Like this thing should go to 0? Yeah? We have to prove it. That's not enough for us to be like, yeah, that's the way I feel. Okay, we have to show it. So I'm actually going to use the squeeze theorem to do this. And this is one of those problems where I show it to you, and it's like the first time you've seen something like this, and you're like, oh, okay, all right. So let me try and come up. I'm going to try and come up with a set of inequalities. I'm going to try and squeeze that in between. So let me write down what I want to try and squeeze. And I'm going to just go for the whole thing. I'm going to write n factorial over n to the n. Watch the way I write it. n minus 1, n minus 2, n minus 3, dot, 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 all the way down to 1. Isn't that n factorial? Isn't that the definition of n factorial? Start at n, then keep coming down until you get to 1. Over, what's n to the n? That's n times n times n times n times n. How many of them? Don't you have n of them? So can you kind of see the pattern here? We had 3 over 3, n over n. And then this next one, 2 over 3, is like 1 less over this. And then 1 over 3, which is like 2 less over n. So do you all agree with that? Mm-hmm. I would like to see if I can come up with some sort of restriction on that. Well, I've got an easy one here, 0. And I'm going to use 0 because I think it's going to 0, right? So I'd like for like this side to be 0. Now, the reason why I'm putting 0 here is because n factorial is a positive number. And n to the n is a positive number, right? So 2 positive numbers are going to always be bigger than or equal to 0. Yeah? So that is a natural candidate. The other side, though, is going to be harder. I need to actually think about this a little bit. So let's just look at each of these factor at a time. N over n is basically 1, right? So would you agree so far that if I put 1 here, that this 1 is bigger than or equal to that piece? Yes? Okay, let's look at the next piece. N over n plus 1. I'm sorry, what? What? N minus 1 over n. I have no idea why I just said n over n plus 1. N minus 1 over n. What can you tell me about that number? It's less than what? It's less than 1, right? So if I put another 1 right here, do you agree that 1 times 1 should be bigger than this times this? Right? Yes? These 2 multiplied should be bigger than these 2 multiplied. Yeah? Come on, yes, no, maybe so? Okay. I'm going to keep going. What about the next one? I'm going to run out of colors, but you kind of get the idea, hopefully. This one right here, that's smaller than 1, isn't it? So if I put another 1 here, these 3 1s multiplied together should be bigger than or equal to these 3 things multiplied together. And I could continue this the whole way, right? Every single one of these is smaller than 1, yes? But if I just do 1s the whole way at the end, is that going to be useful? No, because what I have is a squeeze, where I'm saying, all right, you see that? It's between 0 and 1. That doesn't squeeze anything down, does it? It gives me a range. It's between 0 and 1, but it doesn't actually squeeze. So what I'm going to do is I'm going to go dot, 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 but this last one here, I'm going to look at this one right here. And do you agree that if I put 1 over n out here, that 1 over n is actually bigger than or equal to 1 over n? So all of these numbers, 1, 1, 1, 1, 1, were always bigger than all these factors. But that last factor is exactly equal to this factor. And by doing it that way, what's the right side? The right side is really just what? 1 over n. And that goes to 0 if I take the limit, right? If I take the limit and I let n go to infinity here, I get 0. If I take the limit as n goes to infinity here, well, it's already 0, so it's going to stay 0. So my two n's are going to go to 0, aren't they? And that means this middle piece has to go to 0. That's kind of an interesting application of squeeze theorem right there. So I won't write it down, but you would need to write limit, n goes to infinity here, and then here, limit, n goes to infinity of 0, which is just 0. And then you put the limit on this one, limit, n goes to infinity, and then you just basically go 0 less than or equal to this limit, less than or equal to 0, and you conclude that this goes to 0. I don't know if we're going to be able to do this one, because I'm just making it up right now. N factorial times n factorial over n to the n. Do you still think n to the n is going to win? Like I said, I have no idea if we're going to be able to do this. Shall we write it down? Let's just write out the first few. You plug in 1, you get 1 over 1, that's just 1. Hey, everything's nice? Plug in 2. Don't you get 2 times 1 times 2 times 1 over 2 times 2? Yeah? Let's go to the next one. 3 times 2 times 1 times 3 times 2 times 1 over 3 times 3 times 3. Ooh. Okay. Next one. 4 times 3 times 2 times 1 times 4 times 3 times 2 times 1 over 4 times 4 times 4 times 4. Yeah? By the way, this right here is n factorial squared, isn't it? Just FYI, that's what that is. So like n to the n is growing very fast, isn't it? N factorial grows fast, so maybe n factorial squared will be faster than n to the n. I don't think it's going to. What do y'all think? Just an initial look at this. These twos cancel. We just get 1 for the second term, don't we? How about on the next one? Four thirds. So we have 1, 1, 4 thirds. This one, 4 cancels, 6, 6, 36 over 16. I don't know, maybe someone's going to win. Maybe they're going to compromise. Who knows? Should we go after it? Maybe try a squeeze theorem on it? Let's try a squeeze. Although I don't know if we're going to be able to squeeze it. All right, here we go. I don't know what to try and squeeze it to. What do you think we should try and squeeze that to? Like the last one, didn't it look like it was getting smaller, is going to 0? So let's just write out what this is. N times n minus 1 times n minus 2 times n minus 3, all the way till I get down to 1, right? Over n times n times n times n times dot, 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 all the way out here. But what am I missing on the top? Another one of those, right? So let's try this. I'm going to extend it out. Times n minus 1